Hello. I hope you're doing very well. So what I'm going to do, we are going to uh, cover section 7.4, which is a very important section. So in this section, we are going to discuss how we're going to integrate the rational function. Okay, you know that the rational function is a ratio of two polynomials. So in order to do it, what we are going to do, we are going to break it into some easier fractions. Those easier ones are going to be called partial fractions, and then we take care of it. Okay, so it's going to be there are we kind of 4 different cases that we're going to discuss each type, if you like, and we take care of it. It's not difficult. Sometimes it takes time, to be able to do it, but they're all going to be useful. Okay, so this is what we are going to do, and we prepare your forms for your next quiz. And the next quiz would be up to this section 7.4. Okay, so this is what we are going to have. Okay, this one, right? So this is it. It's going to be integration of rational. Okay, integration of rational. That's it. Integration of a rational functions by partial fractions. The way we're going to do it, you see, a rational function is like it's like a fraction. In the case of the fraction you can have a 2/3, 1/2, etc. But sometimes we have a proper fraction, and sometimes we have a common fractions. The proper fraction is the one that the top is higher than the bottom. For example, if you have 7/5, it's going to be improper. So the way we do it, we change it. It's going to be the same for this type of function. So basically, what we are going to have to start with, suppose a rational function is given to you. So this is going to be our rational function. So suppose f of x, okay, f of x is equal to the e of x is going to be a polynomial on the top, and q of x is going to be a polynomial on the bottom. Okay, so suppose this is a rational function. This is going to be a rational function, where of course the top and the bottom are polynomials, where p of x and q of x and q of x, all of them are polynomials. Okay, are polynomials. So eventually this would be given to you and you want to integrate. So what we are going to do in order to take this integral, in order to evaluate, okay, you want to evaluate the integral of f of x dx, which is going to be integral of px over qx dx. So what we're going to do, first thing to do, so basically what we're going to do, we try to write f of x as a, okay, in general, we try, just give a general idea first. So what we're going to do, we try to write f of x, that rational fraction, write f of x as a sum of partial fractions, as a sum of partial fractions. We have probably seen this type of ideas in your calculus courses, but we are going to show you. So before doing this, first thing to do is we are going to make sure that this f of x is going to be a proper function. A proper means we want to make sure that the degree of the top is going to be strictly less than the degree of the bottom. Okay, so first thing to do, this is very important one, is that the fact that we are going to So let's get, break it into two parts, or just continue. First, we just check to see that if this is going to be the case. Okay, first, if f of x, that rational function, is improper. Okay, improper is like a fraction. Improper would mean, i.e., if the degree of the top, degree of p of x, okay, degree of the p of x is going to be greater than equal to the degree of q of x. It's like when we say, the top in numerator is higher than, okay, or larger than the denominator, then we say is improper fraction. It's the same thing. So it's rare, but you have to do it. So if f of x is improper, means if the degree of the top is greater than equal to q of x, you have to divide it. Okay, so we are going to divide. If this is going to be the case, divide. Okay, we're going to divide p of x by q of x to reduce the degree, okay, by q of x. Okay, to get, if you like, if this is going to be needed, it's just just a couple of problems in your book. You need this one. So if you divide it, you are going to have f of x is going to be something that we call it a quotient function, if you like. It's going to be quotient function. Let's call it g of x. Then there is going to be a leftover. Okay, that leftover is going to be the remainder on the top, r of x over q of x. And of course, this is going to be case. So the degree of the top now, the degree of the top, r of x, is going to be strictly less than the degree of the q of x. So if you need it, you have to do it. Okay, so from now on, we can assume that the degree of the p of x is going to be less than q of x, okay? Because now it would be easy. See, in this case, so what we're going to do in this case, you can integrate it right away. So in this case, when you do it, so in this case, you arrive at the fact that your integral of f of x, d of x, is going to be integral of, it's going to be sum of two functions. So we get the integral of the g of x, d of x, plus the integral of r of x over q of x. So it's not a big deal if the degree of the top is higher, but you have to divide. Okay, so from now on, we can assume that, so the question is going to be how we're going to find integral of rx over qx dx when the degree of the top, okay, so the degree of the top is going to be, so the question is going to be how we're going to find this integral, rx over qx, okay, dx, when the degree of the top now is strictly less than the degree of the bottom. So in most of the problem, this is going to be the case, but if it's not, you just divide it to arrive at this one. Okay, so from now on, we can assume that this is going to be the case that we have, the degree is less than. So what we are going to do, we are going to factor the q of x. Okay, if it is possible, we are going to factor the q of x into the, okay, it may be factored into the so-called linear polynomials, like x plus 1, x minus 1, etc., or the quadratic. Okay, so these are going to be the cases that we are going to have. So what we do is, if we can factor, if we cannot factor it, then then it's going to be another problem. So first thing to do, we are going to now factor. It would be given to you most of the time in the factorial, in the factor form. Otherwise, we can do it. So factor q of x, into two groups, linear polynomial, okay, linear polynomials of the form, linear polynomial, just like the straight line of the form, let's say ax plus b, like x plus 1, x plus x minus 2, x minus 7, and so-called non-factorable, or we call it irreducible, non-factorable. Okay, irreducible. It's going to be irreducible, quadratic. Okay, quadratic polynomial or non-factorable polynomial of the form. Okay, quadratic ax squared plus bx plus c. X squared plus 2x squared plus 9. Those the one that we cannot factor. Of course, they are going to be quadratic. You know that in this case, the discriminant is going to be, the discriminant would be negative. So the delta b squared minus 4ac would be less than 0. You cannot factor it. No, you can see it, that it's not going to be factorable. Okay, so that's going to be the beginning of this type of problems. Most of the time you are here, right at the beginning when you want to do it. But in general, if you have to do a little bit of more, get through it. Okay, so if the degree of the top is higher or equal to the degree of the bottom, you have to divide. You divide by the long division. This is going to be a polynomial. You integrate it. So the leftover is going to be this one. So for this, the degree of the top is less than bottom. So you try to factor q of x. You factor it only into the linear form, means x plus 1, x minus 2, etc. Times it by a quadratic when you say irreducible means it's going to be non-factorable. So something like x plus 1 times x squared plus 9, because the x squared plus 9 is not going to be factorable. Okay, so these are going to be the starting point. Now, in order to write this one as a sum of partial fractions, we are going to consider 4 different cases. Okay, so there are 4. Okay, 4 possible cases. You must know each of those. Okay, we give one from each, and we get to the next quiz. Each of those and be able to show how to take care of it. Okay, so this is going to be case 1, the easiest one. Most of the time we get this one. Case 1. What's case 1? The case 1 is EQX would be factored into the linear factor one. Linear factor means, for example, if QX is x squared minus 4, you factor it into the x minus 2 times x plus 2. Only linear. Okay. So the case is going to be case 1, Q of x. Q of x is a product. Is a product of distinct, means different, no repetition, distinct. Okay, is a product of distinct linear factors. Linear factors. Factors of the form. Okay, of the form. This is it. You see, this is Q of x. You factor. You may factor it into something like, let's say, x minus. Okay, you can factor it x minus, let's say, R1 times x minus R2, x minus R3, depends. Suppose you factor it up to the x minus RK. X minus 1 is mostly, 2 or 3 factors. X minus 1, x times, x plus 1, x plus 7, this type of numbers on. Okay, so I have k factors, if you like. If this is going to be the case, then you are going to break your fractions into the following form. So if this is going to be the case, so what you're going to do is you are going to write, okay, you are going to write this f of x as a, okay, write the function, write r of x over q of x. You still write it as So for each of these factors, you are going to have one fraction. So you get one fraction. This is going to be for first factor, x minus r1. If you have two factors, one of x, okay, this is going to be 1. It's going to be x minus r2. Then you continue to get x minus r3. Up to the variable x minus rk. Okay. And now you have to find the numbers on the top. The numbers on the top, you don't know them. So you are going to call them A1, A2. It depends how many you have. A3, after the A2. Okay, so this is how you write R of x over Q of x as a combination, as a sum of partial fractions. You see, each of these are going to be partial fractions. But they are all linear and they are all different. And remember, the fractions must be proper, means the degree of the top must be less than the bottom. The degree of the bottom is 1. So the degree of the top must be 0. 0 means a constant number. So you write this one as A1, A2, A3 to the AK, where these A1, A2 to the AK are going to be numbers that you have to find. Okay, so this is the case where, okay, where A1 depends A2 up to the AK are going to be numbers. Okay, our numbers are constant numbers to be found or to be determined. To be determined. Okay, that's it. When you do it, you go back and easily you can find your. Okay, so look at the case 1. So the case 1, remember, case 1, all the factors are linear. There is no quadratic. All the factors are linear and they are not repeated. They are not repeated means there is no power here. It is going to be x minus r1 squared, so that gives x minus r1 times x minus r1, which are going to be repeated. So when we say the product of a distinct, distinct, so it means non-repeated for the case 1. Okay, so let's get one example. See how we're going to do it. That would be case 1. So example, we want to evaluate this. Okay, evaluate for each integer. First one, integral r, set x cubed over x squared minus 1 dx. That's it. So it's a rational fraction, as you can see, the degree of the top is higher than the bottom. So what I'm going to do, I'm going to divide the top by the bottom first. Okay, the degree of the top is equal to, see the degree of the top, degree of the p of x is equal to 3. And the degree of the bottom one, which is a qx, is equal to 2. So it is improper. Always the degree of the top must be, okay, the degree of the top must be smaller than the bottom. So we divide line division. It's very rare, but just give you one so that you can see it. So you have to divide how many x minus 1 are going to be in x cubed. Okay, the line division, x would divide by x squared, that would be x. And you multiply cross here, x times x squared would be x cubed. And x times negative 1 would be negative x. Then you subtract for the line division, negative, positive. So that would cancel it out. So that will be an x. Okay, so that's it. So the remainder is going to be x because you cannot divide x by x squared. So what you can do, you can rewrite x cubed over x squared minus 1. You can rewrite it as a quotient, which is x, and the leftover is x over x squared minus 1. Okay, that's the one that I'm talking about, that extra one. but most of the time it's already done. So now, if you want to integrate, it's going to be integral of the x cubed over x squared minus 1 dx. So it's going to be changed into the integral of the first one, which is x dx, okay, plus integral of the second one, which is x over x squared minus 1. So the first one is easy to find. Okay, so this is going to be the target. This is going to be the one that we need to find, call it a star equation. So this part is easy. Integral of the x dx is what? Just x squared over 2. Okay, so we have to find the other integral. Again, x squared plus c doesn't matter. Okay, so we have to find the integral of x over x squared minus 1. Okay, so that would be the question. So now what we can do, we can break it. We say this is it. We want to find what is the integral of x over x squared minus 1. So as you can see, we can factor it into the x minus 1, and x plus 1 dx. So you have to write that into the partial fractions as we talk about it. So the procedure is going to be, this is x, and this is x minus 1 times x plus 1. So we break it. You see you have two factors. So we write each factor first, x minus 1, and this is going to be x plus 1. So these are your factors. So you put something like A1 on the top for the first one, A2 for the second. Some people use A, B, C, D, but I use A1, A2, A3. So we don't mind if you want to use that function. Okay, now we have to find the A1 and A2. So what you are going to do, you are going to just put them together, find the common denominator. The common denominator will be x minus 1 times x plus 1. And over here is a kind of cross multiplication. It's going to be A1 times x plus 1 plus A2 times x minus 1. It's like when you add two fractions. Okay, now you have to find the A1 and the A2. So what we're going to do, we have two fractions. The denominators are the same. So we let the top to be equal to each other. So the top is going to be A1 times x plus 1 from one side plus A2 times x minus 1. And this now must be equal to what? Must be equal to the x. You see, this is going to be equal to the x, where we call it, it's kind of an identity, say, because this is true for all x. You see, it's true for all values of x. Values of x. Okay, when it's true for all values of x, we call it an identity. Now, in order to be able to get these, in order to be able to find the A1 and the A2 over here, okay? So you see, you need two equations to find the A1 and the A2. In order to create, there are different ways to do it. The easiest one is just pick two numbers, because this is true for all values of x. Okay, it's true for all values of x. So what we're going to do, we are going to pick two numbers for the x. You can pick any two numbers you like, but pick some easy one. The easy one is going to be the one that makes this denominator equal to 0. You see, this would be 0 at x equal to 1, and this would be a 0 at x equal to negative. Because if you make one of them to be 0, the other one is easy to find. So you have any choice, you can pick any number you like, but the best one is x equal to 1, x equal to negative 1. See, if you pick x equal to the negative 1, when you substitute, this will disappear like that. So it's going to be A1, it's going to be A1 negative 1 plus 1, and this is going to be A2 negative 1 minus 1. Both sides of the equation that give a negative 1. This would be 0. So we get this next one. Negative 1 minus 1 would be negative 2. So we get negative 2A2. Negative 2A2 is equal to negative 1. So A2 would be negative 1 over negative 2, which is equal to the 1. So your A2 would be 1/2. Right. Okay, so I can use any number I like. Okay, I can use any number I like. So why not? I pick the easiest one. The easiest one is you pick x equal to 1 because x equal to 1. Or to make x equal to -1, I pick -1 first. So make this one 0 right away. Okay, the other number is x equal to 1. So you pick x equal to 1. So if you substitute here, that give you a1 times 1 plus 1. And the other one will be a2, 1 minus 1. See, this will be 0. And x is equal to 1. So 1 minus 1 would be 0. This will disappear. So over here, you have 2a1 equal to 1. Okay, so we get a 2a1 equal to 1. So your a1 would be also 1. Nicely. Okay, so be careful the way you are going to do it. For the easiest one, just pick some nice number, some easy number. The easiest numbers are going to be zeros after the number. In this case, you have 2 zeros, x equal to 1, x equal to -1. You substitute on both sides of the equation and find the a1 and the a2. Now go back and form these fractions. Easily we can integrate it and then okay. So going back, rewrite the one that we did. Okay, this is it. So remember we did have the x over. Just rewrite this one so that you can see it. So that was the one that we suggest, a1 over x minus 1, and the a2 over, just double check it, a1, yeah, a1 x minus 1, and the a2 x plus 1. And now both of them happen to be half. So this is going to be 1/2 over x minus 1, and this is going to be 1/2 over x plus 1. So the integral in question was x over x squared minus 1 dx. Now we change it. We change it to the integral of the half over x minus 1 dx plus integral of the 1/2 x plus 1 dx. If you move the 1/2 out, 1/2 integral of 1 over x minus 1 dx, and this is going to be 1/2 integral of 1 over x plus 1 dx. You know that if you take the u to be x minus 1, u prime is 1. So that's a u prime u, which is going to be natural log. And to take this one to be u x plus 1, u prime is 1. So it's going to be equal to the 1/2 ln of the absolute value of x minus 1 for the first one, plus 1/2 ln of x plus 1 for this one. And you can add the constants. Okay, so that's going to be the integral of the x over x squared minus 1 dx. There was a leftover for the original integral. So the original integral would be x cubed over x squared minus 1 dx equal to, remember we break it into the part that we did have the x, which is x squared over 2, just using one c only. Okay, so it's going to be x squared over 2 for the first one, and the rest is going to be 1/2 ln the absolute value of x minus 1 plus 1/2 ln of absolute value of x plus 1 plus c. And of course, very popular method. In this case is most of the time, this is the only one that we're going to use. Okay, so we got to be careful. We're going to know to update. Most of the problems which could be like this one when you want to evaluate. Okay, so this is going to be type 1. So the type 1, then the factors are going to be linear. So easily you can break it and you get these numbers. When we come back, we give you more and more examples as we go on. Okay, so that's going to be case 1. The case 1 is factor. You see, we get a linear factor, and there is no repetition of linear factor. And the case 2 that we're going to have is going to be linear when you factor it, but they may have a power. Okay, this is x minus 1, maybe x minus 1 squared. This is going to be x plus 1 to the third. If there is going to be a repeated factor, we want to know how we're going to take care of it, okay? So what is going to be case 2? Okay, case 2 is the one that you are going to factor the q of x as we did before. But in this factor, it may contain 1 or 2 repeated factors, okay? So the case 2 is going to be q of x, okay? This is it. Q of x is a product, if you like. Is a product of, again, of linear factors. Let's say a repeated factor, okay? It's going to be a product of a linear factors. Let's say containing, just give you one of them, containing a repeated factor, let's say of the form, so you may have something like, call it x minus r. It's repeated. Suppose, you know, it's to the power, okay, it's to the power m, for example. Okay, most of the time it's, you know, it's like x minus 1 squared, x plus 1 to the third. Okay, so we have all the other factors, but one of them is repeated. If this is going to be the case, okay, so what we're going to do in this case, you are going to add, okay, you are going to add the following. You see, all the other one would be as we did, but let me get to this one. Okay, this is x minus r to the n. Remember, if it was x minus r, this would be your first factor. See, your first factor would be x minus r. Okay, x minus r, and the top would be a. But since it's repeated, you see, if it's going to be repeated 5 times, you must have 5 fractions. If you repeat it 3 times, you must have 3 fractions. So what you're going to do, you are going to continue. You are going to have another one with the squares, second power. And then you continue. You see, you continue up to the what? Up to this power. So if this is going to be 5, you go up to the x minus r to the 5th. Most of the time it's up to the 3. If it's going to be up to the 3, you go up to the x minus r. Okay. So in this case, I'll go up to the what? I'll go up to the, let's say, am and the x minus r to the. So you may have some others, but this is, you know, for this special one, you're going to, in this case, add the following to the what? To the sum of partial fractions. Partial fractions, decomposition of your function, okay, of function. Remember, your function is Rx over Qx. So for each repeated factor, you have to repeat this procedure, if you get it repeated. If something is not repeated, you just, you know, for one factor, 1 fractions. But if it's going to be a repeated one, you have to continue. You have to take care of the repetition to get numbers, okay? So let's get example. See how we take care of this. Okay, example. We wanted to evaluate the integral. Okay, evaluate the integral. See what's going to be this integral. Integral is x. Okay, x over, that's it, x plus 1 times it by x minus 1 all the square. You see, I have 2 factors. One, the first factor is x plus 1, which is a not repeated one. But the second one is a repeated factor because this is x minus 1 squared, okay? So you have the x plus 1 times x minus 1 times x minus 1. So when you break it into partial fraction, you have 3 fractions. So this is the way you're going to take care of it. Look at this one. So you repeat it, x. This is going to be x plus 1 times x minus 1 squared. So it's equal to the first factor. See, the first factor is x plus 1. It's a linear one, so you put the a1 on the top. It's not repeated. There is no power. So you're done with this. You get to the second factor. The second factor is x minus 1. This is x minus 1. So the top would be a2. But it's repeated. Since it's repeated, you have to continue. So you continue, you get to what? You get to the x minus 1 whole square. Again, a3. So you have to go up to the square here. So I stop here. If it was something to the 4, I have to have 1 for x minus 1. X minus 1 squared. X minus 1 to the third, then x minus 1. Okay, so you have to cover it. You have 3 factors, so 1, 2, 3. Okay, so the first one is not repeated. It's just going to be x plus 1. The number like a1 from the top. Then you have the x minus 1 as usual. It's going to be a2. But since repeated, you go on to get to the repetition power. We call it multiplicity. The multiplicity is 2 because it's repeated twice. Okay, so just get into the twice one. But so on the top is going to be a1, a2, a3. Okay, so what you're going to do, you have to find the a1, a2, and a3. Okay, so again, you get the common denominator. The common denominator would be the product of the factor, which is the same as the original one. X plus 1 times x minus 1 squared. Now the top one as the fraction, you see the top one would be a1. Missing factor is like dividing this one by the x plus 1. If we divide x plus 1 and x plus 1 cancel out, the leftover is going to be x minus 1 squared. Plus x1, if we divide this one by the original one, 1x minus 1 will be out. So that you a2 x plus 1 times x minus, like ordinary common denominator that we do in algebra. And this last one, if you divide this one, the new denominators, and the old one is to cancel out. So the leftover is going to be x plus 1. Okay, so that's going to be the top that we're going to have. Okay, I repeat it again. Find the common denominator. This is going to be the common denominator, the product, like this one. For each one, it's like dividing the old one by the new one. These two will cancel out, so the leftover is x minus 1 squared. If we divide this one, 1 of the x minus 1 will cancel out. The leftover x plus 1 times x minus 1. And if you add the last one, the leftover will be x plus 1. Now let the top to be equal to each other, to make that identity, to be able to, to find it. Get these, okay, number that. Okay, so that's it. Going back and let them to be equal to each other. And then we're going to take care of it. Okay. So what is going to be the top one that we're going to have? Okay. So check this one. Okay, so we are going to continue. So I let the top two equal to each other. So on the other side, I have, you see, this is what we're going to get. When you let them to be equal to each other, you're going to have the a1 times x minus 1 times x plus 1. And that's a2 times x minus 1, x plus 1. And you have the a3 times x minus 1 all squared. But this is going to be equal to x. Okay, but again, you know that this would be true for every value of x. So what we're going to do, we are going to pick some nice x. So it's going to be the nice. The nice is going to be zeros of the denominator. Look at the fractions that we have. In the denominator, you have x plus 1, divided equal to the 0 that will be x equal to -1. So this is one nice number. You get x equal to 1 from this one. But since the repeated one, you're not going to get the third one. So the third one, you have to pick it yourself. So first, pick the one that you have, then you can decide what are we going to do about the third one, okay? So there you are, the numbers, we can start with x equal to 1. Both sides, if you substitute here, it's going to be a1. It's a 1 minus 1, it's not going to be 0. You can write 0 right away, we accept it. And I explain it. It's going to be a2. That would be 1 plus 1. And that's going to be a3. That's a 1 minus 1 squared. And this is going to be, you see, these are going to be out because of the x minus 1. 1 minus 1 would be 0. 1 minus 1 would be 0. So you have 1 plus 1 would be 2. So that will be 2a2. 2a2 equal to 1. So a2 would be half. So this would be 1. Okay, so I pick x equal to 1 because this would be 0 and this would be 0. Next, the other number that we have, we can pick x equal to -1. The zeros are in the other denominator. So make this one equal to the 0 and this would be 0. You can write it down right away, but I'll explain it. So it's going to be a1 -1 minus 1 times -1 plus 1, a2 -1 plus 1, and the a3 -1 minus 1 all squared, and the x is negative. Okay, so we substitute x equal to -1 for all of them. Now again, you see, -1 plus 1 would be 0. This would be 0. And this is going to be -2. -2 squared would be 4. So that gives you 4a3. Okay, so it gives you 4a3. And the 4a3 equal to the -1. 4a3 equal to -1. So a3 would be -4. So that gives you your second number. Okay, so we have two factors, so we choose zeros at the denominator, and in this case, you'll be able to find two numbers. You need another number, but you don't have the nice one, because the factor only were x minus 1 and x plus 1, and one of them was repeated. So you have to pick this number yourself. Pick something nice. You can pick any number you like. X equal to 10,000, 1, not 1, 2, 3, or 0. The easiest case is 0. Okay, so it's optional. The solution would be the same if you pick any number you like. I pick something easy, 0. So go back, substitute x equal to 0 carefully and evaluate. So that gives a1 is 0 minus 1, 0 plus 1. Okay, it's going to be a2, 0 plus 1, and a3, 0 minus 1, all squared, and of course this would be 0 because you pick the x equal to 0. Now over here that would be -1, -1 times a +1, that is -1, so that gives a, so this would be -a1. Over here this is going to be just a +1, so that will be a2. And here that's going to be 1 squared, it's going to be a3. a3 equal to the 0. So you have a relationship between a1, a2, and a3, but we already got the a2 and the a3. So we can substitute, say, oh, that I have the a2, which is a half. Okay, and I have the a3, which is a -4. So I substitute here. So -a1 is the missing one. a2 is half. And a3 is a -1/4. -1/4. 0. So solve for, for your a1. Okay, so this is going to be a1 is the missing one. Yes. So the a1 is the missing one. So what we can do, we can move it to the other side. It's going to be -a1 and this is going to be what? It's going to be negative half plus a quarter. Okay, and you can simplify it. Common denominator would be 4, or this is going to be 4 multiplied by negative 2 4 plus 1 4. So that gives me negative quarter. Okay, so negative A1 is equal to the negative quarter. So A1 would be a quarter. Now you have all the coefficients. It takes, of course, a little bit more time than you compare it with the other one because you have this distributed. It's nice. Okay, now we go back and we write the given integral rational function as a combination of these numbers that we have. Okay, so this is it. Get back to the original, but originally you want to find this integral x over, okay, x plus 1 times x minus 1 all squared dx. Remember, we change it. We change it to the what? We change it to the a1 over x plus 1. Okay, and the a1 is the quarter. So that would be quarter. And the plus x minus 1 over a2. A2 is 1/2. Okay, that is 1/2. And what plus the repeated one, x minus 1 squared. And the top was a3. And what is the a3? And the a3 is a negative quarter. Okay, so that gives you a negative quarter over here. Let's make sure I didn't miss anything over these numbers. Okay, so that's it. So I got the negative quarter here, and that was the 1/2 and a quarter. We simplify it. Yes, nice. So we are going to integrate. You pull out these quarters to integrate, so it's going to be equal to the quarter out. This would be 1 over x plus 1 dx, which is the integral of the ln function. The next one is going to be 1/2. Integral of 1 over x minus 1 dx, which is going to be natural log. Okay, the natural log, that last one, you see, you have to move it up. So, sorry, this is dx. So you pull out the negative quarter, and you move this one up, x minus 1 to the negative 2 dx. So this would be a quarter ln of absolute value of x plus 1. And this would be half ln of x minus 1. And this would be negative quarter. This is like u to the negative 2. Okay, because your prime is 1. Take this one, u, it's going to be u to the negative 2. So it's going to be u to the negative 1 over 1. So it's going to be x minus 1 to the negative 1 over negative 1 plus constancy. So finally, it's a quarter ln of the absolute value of x plus 1 plus half ln of x minus 1. And this last one, negative with the positive, is going to be a quarter times x minus 1. Okay, it's going to be times x minus 1 because, you know, we bring that bubble down, plus the constant c. So this would be the integral of x over x plus 1 and x minus 1 all the square. So that's the case that you are going to have one repeated factor to get this one. Okay, again, you know, it takes time to be able to do it. We are not going to make it complicated on the test or the quiz because it takes time. You know, we have a couple of, you know, at most x minus 1 square or just, you know, x minus 1 to the third. But because that partial fraction only takes steps. But easy, not difficult. They should know how to do it. For that repeated factor, we have to go on x minus 1 square. If you turn x minus 1 to the third, you continue to get those numbers up. Okay, so that is going to be your second case. So the second case is the one that we have a repeated linear factor. Okay, a repeated linear factor. What's going to be case 3? The case 3 is you may have a quadratic. Okay, the non-factorable, we like quadratic. Okay, so this is going to be case 3. You see, case 3 is you factor case 3. You factor the denominator. The denominator can have some linear factor between one, but it may contains, okay? It may contains a repeated, you may contain a quadratic form. Something like x squared plus 1. We know that x squared plus 1, x squared plus 4, x squared plus 9. We cannot factor it. So you may have one of these, okay? So this is going to be the case, the Qx contains, if you like. This is it, Qx in the repeater, in the contains. Okay, contains, let's say, irreducible factor or non-factorable. Irreducible, you like non-factorable, non-factorable. Irreducible or non-factorable factors, that factors of this form, of course, without repetition, non-repeated, without repeat, if you like. So Qx contains irreducible, non-factoring, non-repeating one, okay? Non-repeating one factors, okay? Qx contains irreducible factors without a repeat of the form, if you like, of the form. This is a general form, something like ax squared plus bx plus c. It's the one that, you know, if you form the b squared minus 4ac, we see that it's going to be non-factorable. And the one that you have here are going to be x squared plus 1, x squared plus 4. So you can see it right away. If this is going to be 1, so what I'm going to do is, in this case, if you have anything else, you just follow the instruction that we talk about it. In this case, we are going to add, okay, for this special one. So we're going to do, you are going to add, okay, you are going to add this factor, add the term. You see the bottom one is ax squared plus bx plus c. It's a non-factorable, it's quadratic. Remember, the degree of the top must be 1 less than the bottom. Since the degree is 2, you have to write a polynomial of the first degree here. Polynomial of the first degree is going to be this form, ax plus b. Now we call it a1, b1 for those cases. So in this case, you add this one, okay, to the sum of, partial fractions. Partial fraction decomposition, decomposition of the function, okay, of the R of x over Qx. Okay, so this is going to be the case. And when you do this type of problem, most of the time, you are going to use the tangent inverse case for this integral. Okay, so I'm going to show you how you do it and you see it. Okay, so this is going to be the one. So we have a quadratic non-factorable without any power. So if you have a power, that will be the case 4. And you have to repeat it, that the one that we did. Okay, and that will be a very big case to check. Okay, let's see how we're going to handle this one. Example, this partial fraction decomposition takes time, much higher than or bigger than the other one. But I'm going to show you a different way to do it. Okay, there you are. We want to evaluate this interval. Evaluate H interval. Say that's going to be one. So let's this one or just give one. So the integral is you have the x on the top. Okay, and you have the x times x squared plus 1 down the bottom. You see, as you can see, it's a two factor. The first factor is x, is a linear. The second factor is x squared plus 1. It is quadratic, this quadratic, and you cannot factor it because of the x squared plus 1. Okay, so the question is going to be how we're going to handle these type of problems. So this is how we're going to create. Okay, solution. Let's break it into parts. That's it. This is going to be 1 over x times x squared plus 1. So the first factor is x. It's a linear. See, linear. The power is 1. So we put on the chart just a1. It's not repeated. If it was x squared, you have to go on. So we are done with this one. We get to the next one. The next one is what? The next one is x squared plus 1. The degree is 2. So you have to put the linear on the top. Okay, the polynomial of the first degree. The polynomial of the first degree would be like this one, ax plus b. You can use the a and the b, but this is a1. I'm going to use a2x. a2x plus a2. If you don't like it, you know, you can use a, b, c. But I use this method. Okay, so this is how I'm going to break it. So I break the first one because it's a linear, but I break the second one. This is quadratic. Since it's quadratic, I should have on the top part a linear function. Now find the common denominator as we did for the other one. So the common denominator would be for that. It's going to be x times x squared plus 1. On the top, you know, just a 2, you know, like dividing this one by the old one, x and x will disappear. You get the a1 times x squared plus 1 plus divide these two, so we have to multiply a2x plus a3 times it by x. Okay, it's common denominator. Instead 2 is like the product is going to be the common denominator, just use kind of cross multiplication. Now let the top two cut each other. It's going to be a1 x squared plus 1 plus a2x plus a3 times x equal to 1. You see, you have this is going to be your x. What you are going to do, you are going to, that's it. You have to find the a1, a2, a3. You need 3 numbers if you want to use that method that we talk about it. And it can be done, you know, if you want to use those numbers. But you have only one number to get the zeros of this denominator, x equal to 0. You can put x equal to 0 and that give you one of these. But you have 2 more to go. And you don't have any number because of the x squared plus 1. So you have to pick 2 numbers to find. I'll give you 2 different methods for this one. You can use either one. Okay, the next one is going to be useful for the case 4. So it's not bad to learn both of them. So the method that I'm going to use, the first one is the one that we talk about it. Okay, or we can use that one for this one too, but you know, just give it the last, you know, the method that I talk about it for the last case. So 3 numbers. X equal to 0 is going to be one of them. Because make this one 0. So quickly you can take one of those groups. So let's do it 0. So let's give a1 0 plus 1. You see this would be x0, so it's going to be a2 times 0 plus a3 times 0 because the x is 0 equal to 1. Since you multiply by 0, this will disappear. Okay, so you have only A1 here. Okay, we get the A1, and on the other side, we get 1. So quickly you find one of them. Okay, but you need 2 more. Okay, 2 more numbers. So in this case, you can pick 2 nice numbers, easy number like x equal to 1. You have to substitute, okay, on all of them. So that give you A1, 1 plus 1 plus A2 plus A3 times 1 equal to 1. So 1 and 1 would be 2, that give you 2A1. And over here, you just multiply. This is going to be A2 plus A3 equal to 1. Okay, so as you can see, A1 is equal to 1. A1 is equal to 1. If you substitute that, you get 2 plus A2 plus A3 equal to 1. So that gives you A2 plus A3 equal to the 1 minus 2, which is equal to 1. So you get only one relation, not the result. See, when you put one number on other number, A1 equal to 1, you just get A2 plus A3 equal to 1. You keep it. You need one more number. You put x equal to -1. That gives another equation, and a system of 2 equations, 2 variables. Eventually, you can find it. Okay. So I just put the one more number. Okay. So x equal to the 0 will give you one of them right away, A1. But you need 2 more numbers. So I'm going to pick x equal to 1 and x equal to -1. So I put x equal to 1, I simplify it. You're not going to get anything quickly because there is going to be a relationship between these 3. So you put the A1 equal to the 1, and so far you have A2 plus A3 equal to 1. So go continue, get another number. Okay, so get x equal to the -1 again on both sides. Then I give you the second method, maybe like the second. Okay, so I go on and just put x equal to -1 on both sides. So if you put x equal to -1, so you are going to have A1 times -1 squared plus 1 plus, that was A2x plus A3, that gives you A2. Your x is a -1 plus A3. Okay, times it by x. So it's going to be times it by -1 equal to 1. Okay, this is you substitute x equal to -1. Now, -1 squared would be 1. 1 and 1 would be 2, so that would be 2A1. And over here, this is it. So it's going to be plus -A2 plus A3 times it by -1 equal to 1. So we get 2A1. And the negative with a positive, A2 minus A3 equal to 1. So you gotta have this equation. But your A1 was 1. So the A1 is 1. You substitute, so that gives you 2 plus A2 minus A3 equal to 1. So A2 minus A3 will be 1 minus 2. So the A2 minus A3 would be what? Would be a negative. See. Remember that's A2 minus A3, and you have the A2 plus A3 here. So you put them together. So you have that the A2 plus A3 is equal to 1. And the A2 minus A3 is equal to the negative. It's a system of 2 equations to variable, solved by adding addition method. So that gives you 2A2 equal to 0. So A2 would be 0. Okay, so A2 is equal to the 0, and you substitute in one of these, that gives you A3. Okay, so I substitute in the first part. So that gives me 0 plus A3 equal to 1. So A3 would be also equal to. Okay, so it takes, of course, more time to do it. So we go back and we put them together and we can find the integral. Okay, there you are. This is the original one. 1 over x squared plus 1. Okay, that was equal to the A1. Your A1 is 1 over x plus A2x. A2 is 0. 0 times x plus A3, 1 over x squared plus 1. So which is going to be 1 over x plus 1 over x squared plus 1. Now you integrate. Integral of 1 over x times x squared plus 1 dx. Okay, is equal to the integral of 1 over x dx plus integral of 1 over x squared plus 1. Now we are ready to integrate. The first one would be ln x, and of course the second one is tan inverse. And inverse of x plus c. So that would be the given integral. With that. Okay, so this is what would happen for the case that you are going to have okay, you are going to have a quadratic one, which is going to be a non-repeated problem for that. That takes you time to be able to do it. Now, you see this method that I did for the numbers was nice, and it can be done. So there is another method to take care of these problems, and there is a very famous problem. So I give you that one, and I'm using this method, the second method. Then you can pick the one that you like. Okay, the next one is very popular problem in this format, and you see it in this course for the first time. And if you continue some other places, that you get this one too. Okay, it's very popular integral. So I'm going to find this one for you. This is going to be again. So this is how I explain the other method that you can find that, especially you need it for. You see the one that I did. There was a linear factor, but for this integral, it's not going to be the case. Okay, so we want to evaluate this integral. That's the best problem in this section. In your book. Evaluate the integral. Let's see what's interesting about this. See, that's the integral. It's a x cubed plus x squared plus the 2x plus 1 divided by x squared plus 1 times it by x squared plus 2 and the dx. You see that's 1. You see the denominator contains 2 quadratic factors, and they are not factorable. You see x squared plus 1 is not factorable, x squared plus 2 is not also factorable. And there is no linear one, okay? So you have to change it to the partial fraction first. There you are, solution. The partial fraction, let's see, x cubed, x squared, 2x plus 1 divided by x squared plus 1 times x squared plus 2. Now, for each quadratic factor, it's going to be x squared plus 1. It's not factorable, so the degree is 2. So you have to put a near one on the top. So the near one is going to be something like a1x plus a2. Okay, so this is going to be the top one we're going to have. Okay, and then plus. So it's not repeated one, so we're done with the x squared plus 1. Now we are going to continue getting another one. The other one is going to be x squared plus 2 Again, it's not factorable, so you have to put similar one over here. You already will use the A1 and A2, so it's going to be A3x plus A4. Okay, so you need to find the A1, A2, A3, and A4 for these, for these special number we're going to have. Okay, so this is going to be the case. Okay, so now what we're going to do is find the common denominator on this side. So it's going to be equal to, so that gives you x squared plus 1 times x squared plus 2. Okay, and the top is kind of cross multiplication. So we're going to have the A1x plus, okay, A1x plus A2. Because when you divide the old fraction, old denominator by the new one, this 2 cancel out, you get x squared plus 2. So that's going to be times it by x squared plus 2 plus, we repeat this one, this will cancel out, so we get A3x plus A4 times it by x squared plus 1. Okay, now you let the top two equal to each other to be able to take care of it. So the top one are going to be the one denominator here. So I write this one first. So you are going to have A1x plus A2 times it by x squared plus 1. Sorry, x squared plus 2. And it's going to be plus A3x, okay, A3x plus A4, and multiplied by x squared plus 1. And this must be equal to the x cubed plus x squared plus 2x plus 1. You see, you have to find the A1, A2, A3, A4. The previous method that we talked about, we did have some nice number. Remember, zeros after the numerator. We substitute and we easily, some of them will quickly zero and be able to do it. Over here, they are non-factorable. So you don't have any nice numbers. So if you want to pick number yourself, you see the unknown, you have the A1, A2, A3, A4. This is 4 unknown. So this means you have to put 4 numbers here. And the result is going to be a system of 4 equations, 4 variables, be able to do it, which is not an easy procedure to do. It can be done to pick 4 numbers. But there is another method for all of these that you can apply. What is the other method? You see, this is a polynomial. Combination of powers of x. So what you can do, you can simplify this one, do the multiplications, write it down as a polynomial. The polynomial, you see, you get the x cubed here, x squared, x, constant. The polynomials are equal to each other if they have the same coefficients. You see the same, each monomial, this is x cubed. If you have the x cubed here, the coefficient of the x cubed to the left and the right must be equal to each other. The coefficient of x squared equal to each other. The coefficient of x equal to each other, and the constant equal. So you use this idea to quickly find that 4 equation that you were looking for. So this is much easier for this type of numbers. Okay, I didn't use it for the other one. I just want to show you different methods. Because when the numbers are available, that's easy, but not for this one. So what I'm going to do is multiply it. Multiply it, simplify it, put it in order up to the third, to the second, to the first, and constant. Okay, it can be done quickly, really. So I just multiply it for you. You see, that's it. Use the FOIL method, multiply this. So it's going to be A1x cubed, okay, plus 2A1x, then A2x squared, plus 2A2. That's the first one. Continue with this one. It's going to be plus A cubed x, A3x cubed, and that's going to be A3x plus you multiply this one plus A4 x squared. And you multiply this one, that will be A4. Okay, and this is going to be x cubed, x squared, 2x plus 1. Now put them nicely together. Let's start with the x cubed. You see how many x cubed have? A1 x cubed, and you get the A3 x cubed. Factor out the x cubed, so that you what? That give you A1 plus A3 times it by x cubed. That's the x cubed. Okay, then get the x squared. See, x squared. So it's going to be plus A2 plus A4 x squared. Okay, that's going to be x squared. Then the x's, you see x, x, and the x. So factor out the x, that will be 2A1 plus A3 times x. Then the constant, the leftover will be the constant. We have 2A2, 2A2, 2A2 and A4, A4. And this is equal to what? X cubed, x squared, 2x plus 1. You see, you have a cubic polynomials to the right, and you have cubic polynomials to the left. Two polynomials are equal to each other if their coefficient of each monomial would be the same one, which means, you see the coefficient of x cubed is A1 plus A3. This must be equal to the coefficient of x cubed here. So this means A1 plus A3 must be equal to 1 because of the coefficient of x cubed. Okay, and we do the same thing for the other ones. Okay, for the other ones, the coefficient of x squared, you see, this is the coefficient of x squared, and this is the coefficient of x squared. So the coefficient is going to be A2 plus A4, and the coefficient of x squared is 1. Okay, and we continue to getting the rest. The coefficient of the x, this is it, must be equal to the coefficient of the x. So we have the 2A1 plus A3, and over there we get a 2. See, that's going to be 1. And the last one is going to be just the numbers, the constant. This is going to be the constant, and the constant is 1. So that will be what? That will be 2A2 plus A4 equal to a system of 4 equations for variables. You solve it, you get these 4 and go back. Okay, of course, this is not much better than the other ones. So you can substitute 4 numbers, right? It would be quite a lot to evaluate. So this method can be used for all of them, all the other problems that I did, but especially for this one. Now, big things, you know that we have to use elimination method to take care of it. You don't need any linear algebra or anything. You can do it right away. Okay, so for example, this is A1 and the A3 and the A1 and the A3. We can pick these two. This is going to be, let's call this one 1, 2, 3, 4. Okay, so what I'm going to do, I'm going to pick the 1 and the 3. Okay, the 1 is A1 plus A3, which is equal to 1, and the A3 is 2A1 plus A3 is equal to 2. Okay, so I pick the 1 and the 3. Now use the addition method to simplify it. I want to eliminate the A3, so I multiply one of them by -1. So this one by -1. So I'm going to have a negative A1, negative A3 equal to the -1. And this is going to be 2A1 plus A3 equal to 2. So these two cancel out. So that gives you A1, which is equal to 1. So it's going to be A1. I substitute A1 in each of these, like I put it here. So that gives me 1 plus A2 equal to 1. So A3 would be 7. A3 is 7. Okay, so it's going to be 2 factors. Repeat it again, consider 2 and a 4. Okay, the 2 is A2 plus A4 equal to 1. That's equation number 2. And the 4 is 2A2 plus A4 equal to. It's very similar. Again, I simplify this, the first one. So by -1, so that will be negative A2 minus A4 equal to negative 1. And the last one is going to be 2A2 plus A4 equal to. So adding together, these two cancel out, so the A2 will be 0. So I put it here. So the 0 plus A4 will be 1. So A4 will be 1. There we are. So I have all the numbers that I need. I go back and take it away. Okay. So if you go back and rewrite it, this is what we're going to get. It's x cubed plus x squared. Okay, x squared plus 2x plus 1. Divided by y. X squared plus 1 times x squared plus 2. So that was x squared plus 1. You see, it was a1x plus a2. A1 is 1, so that gives a1x plus a2. A2 is 0. So that gives me 0. And this is x squared plus 2. A3, okay, it is A3. A3 is 0. Just double check that is A1. So A1 and A2 is A2. A2 is 0. Yes, that's correct. Then I got the, okay. So that's correct. And the second part, I got here. Okay, the second part was A3. A3 is 0. So that gives me 0 plus A4, which is 1. So that gives me, that's going to be the number. Okay. Let's double check it, make sure that everything seems to be all right. It's going to be x over x squared plus 1. Use some numbers. Seems to be all right. And my note is a little bit different, but I think that's correct. Yeah, I made a mistake on that. So this is it. You get the x over x squared plus 1 on the top. Okay, plus 1 over x squared plus 2. Nicely can be done because the first one can be done by LLX, the second one by tan inverse, and then that. Okay, so it's a very nice method. You have to use this one for this group. Have a couple of problems in the group, so you better use this one, and it's a very popular method. You can use it for all of them. But when the numbers are available, it's easier to do it. So the final integral, I write down here, so we have it on this page. So it's going to be x cubed plus x squared plus 2x plus 1 over x squared plus 1 times x squared plus 2. Okay, dx. So we change it into this. It's going to be x over x squared plus 1 dx plus 1 over x squared plus 2. Okay, it's going to be x squared plus 2 dx. That is going to be the case that we're going to have. Okay, dx. And easily can be done. You see, this is x squared plus 1 x. You need u prime on the top. You can use u substitution if you like. I don't need a 2 on the top. So what I can do quickly is just use those short form. I divide by half and multiply by half. It's the same thing. X squared plus 1 dx. And of course, this can be done by the tangent inverse. X squared plus 2. Okay, x squared plus 2 dx. So the first one would be ln of x squared plus 1, and this is 1 over x squared plus a squared. You can take care of the value tangent, okay? And you can use your substitution for this one if you like. So eventually, this is going to be the result. So it's going to be equal to, the first one is a 1/2 ln of x squared plus 1. And the second one, tangent inverse, a squared is 2, a is radical 2, 1 over radical 2, and inverse of x over radical 2. 1 over a and inverse of x over 2. That's C. That would be the final answer for this one. Okay. So we have a couple of them. We are going to take care of it when we get to the, okay, we practice one for the next quiz. So check this one, and you have one in your assignment to get this kind of stuff. Okay, so that was case 3. As you can see, case 3 takes times. Then we have these a quadratic factor, because it's not difficult. It takes times. Maybe you're going to break it. Now, what's going to be case 4? Case 4, you may have a repeated quadratic. Good luck. It takes a little more time, but we have one very famous problem to take care of. And okay, what is case 4? Case 4, q of x contain, okay, this is it. Qx contains a repeated non-factorable, contains a repeated non-factorable quadratic. Okay, it's going to be repeated quadratic of the form. Okay, this is going to be fun. Of the form. It may be something that ax squared plus bx plus c to the power, as we talk about it. It's going to be just a square, really, because it takes so much time. It's going to be higher. If this is going to be the one that, like the linear one, you have to repeat these fractions. Okay, so what we're going to do, we are going to, this is it. We're going to add the following. And this is it. See the first one. It's ax squared plus bx plus c. We pick something like a1x plus, let's say, b1. Then you repeat this one. Ax squared plus bx plus c squared, and then it's going to be something like a2x plus b2, and then you have to go on to get to the repetition power. Just 2. It takes so much time. So if you like, it's going to be anx plus bn. So you're going to add this one to the sum of partial fractions of that Rx over Qx. Okay, you're going to do this one to be able to do it. It's nice, but the examples are just a couple of cases that we're going to have. But the best one is, again, the power is most 2 in this case, because it takes time to do it. So the best example is the following. You have it in your book. Make sure you have a look at it. They are very popular, famous problem in calculus. There are not that many of these. Evaluate the integral. And this is it. It's the most you can have. So you have x squared plus x plus 1 on the top. And you have x squared plus 1 all square dx. So that's that. See, the denominator, it's x squared plus 1, non-factorable. That's a square. It's repeated one. See, if there is no power, it's non-repeated. You know how to do this one. Just put in a1x plus a2 on the top. Since it's repeated, we repeat it again. Just write 2. Because you should have 2 fractions. Okay, you should have 2 fractions for the decomposition of this one. And then the same procedure that I talked about. That part takes that. Otherwise, this integral is not that. Okay, so the solution is going to be, this is it. So you have the x squared plus x plus 1 over x squared plus 1 all squared. So you break it into 1 factor x squared plus 1. Since it's repeated, you have to repeat it. X squared plus 1 all squared. On the top, a1x, I write a1, a2, plus a2 for the first one, a3x plus a4 from the other. That's it. Okay, since it's repeated, you have to go up to the repetition. It's 2, you know, it's going to be 3, you know, it can be done, but 3. Good luck. It's quite what to do. Okay, common denominator to get back to the original one. This is going to be x squared plus 1 all squared. If we divide by this one of them cancel out, there's one left over. So we get a1x plus a2 times it by x squared plus 1. And you divide the second one, you see everything that cancel out, you get a3x plus a. Just when you know, when you add 2 fractions, this is the way you find the common denominator. So you let the top to cut each other. Okay, they'll take it up a1, a2, a3, and a4. So there you are. The a1x plus a2 times it by x squared plus 1 plus the a3x plus a4. This must be equal to the x squared plus x plus 1. Again, you don't have any numbers to substitute. You can substitute if you like. You need 4 numbers. Because we have 4 unknown. So since we don't have the numbers, FOIL it and use the fact, you know, that the fact that the 2 polynomials are going to be the same. Okay, 2 polynomials are going to be the same if they have their monomials. Okay, the corresponding monomials would have the same coefficient. Okay, FOIL it. So I'm going to FOIL this one, multiply, go forward. So that gives me a1x cubed. Then I continue with the a1x plus a2x squared plus a2. And that would be a3x plus a4. And this is going to be x squared plus x plus 1. Okay, put them nicely together. And we have one a3, so it's going to be a1x cubed. Then you have the x squared. How many? One x squared only. Okay, so this is going to be just plus a2x squared. See, this is 1. Then you have the x's. You have 2 x's. Factor of the x. So that will be a1 plus a3x. The leftover is going to be constant. Get the a2 and the a4. On the other side, we get the x squared, x1. Okay, that's the case. Now the coefficient to be equal to each other. You see, this is x cubed. We don't have any x cubed here. It's like the coefficient is 0. You see the x cubed. We don't have it here, it's 0. So the a1 is 0. That's the a1. a2, the coefficient of the a2. See, this is the x squared, so the a2 would be 1. Okay, Then we have the x, the coefficient of the x here is a1 plus a3. Okay, a1 plus a3, coefficient of the x here is 1. So that is one equation. And lastly, this is it. We have the a2 plus a4, and this is equal to the 1, 2. Okay, so these are going to be your 4 equations. So we get a1, 0, a2, 1, and these 2 equations. And now this is it. If you put the a1 here, so that gives 0 plus a3 equal to 1. So that gives a3 equal to 1. Okay, and if you put the a2 here, so the a2 is 1. 1 plus a4 equal to 1. So a4 would be 0. A4 is 0. The more 0 they give, the resultant integral is going to be 0. So go back here. Substitute to see what you have to integrate. Okay, so this is what we are going to end up. We have the x squared plus x plus 1 divided by x squared plus 1 all squared. So it's going to be equal to what? a1x plus a2. What's a1? a1 is 0. 0x plus a2, which is 1 over x squared plus 1. That's first one, plus a3x. What is a3? a3 is 1. So that gives x plus a4. a4 is 0. a4 is 0 divided by what? Divided by x squared plus 1 all squared. So you end up with what? 1 over x squared plus 1 plus x over x squared plus 1 all squared. Easily can be done because this is a tan inverse. And over here, you move this one up, u prime, you get it right. That you will find out the randomness. Okay, the first time that I did this one, when it was face to face, the first time that I teach, I made a mistake. One of these coefficients, I think that was a -1. If you put a -1 at the end, you get here 1 over x squared plus 1 over square, which is not easily to find. But I did find it. I just used the trig substitution to do. Say I picked the x to be 10x, 10 squared plus 1 would be secant squared, then I was able to do it, but it takes so much time. Then I realized that at the beginning I made a mistake. But it was a nice problem. I kept it in several times. I don't know. This is just double check. The one that we're going to give you, it's not going to be complicated. Okay, but now let's find out. This is the integral that we have to find. So the original integral is this one. X squared plus x plus 1 over x squared plus 1 all squared. This integration in calculus 2, you are not confused quite a lot. But if you take that course I told you, differential equation, rational functions, so much used over so many times. There are a number of problems that you'll be involved with this one. So just keep them for that course. Okay, in this course, we are going to have a couple of those easy cases, or the factors are just linear, like the one we did. And for some of them, you have to show the method. I will tell you later. Okay, so this is it. So we break it into 2 integrals eventually. The first one is going to be 1 over x squared plus 1 x. And the second one would be x over x squared plus 1 all square dx. Okay, so the first integral is clear. This is just tan inverse. Tan inverse of x. We will add constancy later. The second integral, you have to move it up and just use your prime to do it for it. Okay, you move it up, that gives x squared plus 1 to the -2. If you pick this one to be u, U prime would be 2x. We can use the U substitution or just multiply by 2 and divide. That's shortcut that I talked about. This is going to be the case. There is an index here. Okay, so in fact, it's going to just, it's like to take this one, U is like U to the -2. So it's going to be 1/2 U x squared plus 1 to the -1 divided by -1. That's the constant C. If you simplify it, that gives -1 over 2 times x squared plus 1. So if you put them together, the final answer, x squared plus x plus 1 over x squared plus 1 over squared x is equal to tan inverse of x minus 1 over 2 times x squared plus 1 plus the constant. So the best example, that you have in your book when you get to this book. Otherwise, the rest are just going to be a standard, and we are not going to make it complicated. Okay, so just get through it. Give you a couple of them. One from each on the coming quiz. Quiz is on the next week. So this is it. 7.4, as I told you, a little bit more involved, but not bad. We are going to cover one more section on integrations, and this is the one that we call it the improper integral, and that will be used for the second part of the course, and then be done with the first part. That takes time again. It may take us to the next test, but try to finish it. Okay, so just give you introduction of the sequences a little bit for the next test. Okay, so I post a practice quiz for you, and of course your quiz. That your quiz is going to take home. You better do it yourself, and you submit it by that time. Okay, I think it's going to be a big fun on Tuesday. I'll double check it and post it over the weekend for you as usual. Okay, I just graded, I think, the first 3 questions, and I will continue to try to finish it by tomorrow. And you post your grade and the solution. If you have any question about that one, you let me know. Okay, so just keep up. Quickly read these 2 sections and talk about it. That the substitution and this one you need for your quiz. Okay, I'll try to post another one for you during the week, and that will be that famous 7.4. It's a very dense section. But since we did it quite a lot for this course, and in case you want to take calculus 3, so we spend a little more time on it and make sure you cover everything. If you get a good understanding of that section, it will help you quite a lot for most of the part of the final part of the course. Okay, so I give you. Okay, have a good one. Take care as usual. If you need anything, email me. Office of anything, just email.